Welcome to the video lesson for section 5.5, multiple angle formulas, as well as sum to product and product to sum. Let's get started. To begin with, we have our double angle formulas. We see there are three of them. We have the sine of 2u, the cosine of 2u, and the tangent of 2u. There are actually a few other versions for the cosine of 2u, but I'm choosing one just to make things a little simpler. We're going to go through some examples of how to apply these formulas given certain information. For our first example here, we want to find the sine of 2u, and we are given information that the sine of normal u is 5/13. So what we're going to do is look at our formula, which is sine of 2u is 2 sine of u cosine of u, which means in order to answer this question, I am missing the cosine of u. To identify the cosine of u, we're going to take the given information, sine of u equals 5/13, and use that to construct a triangle. So I have the following triangle, where I know my opposite side is 5, and my hypotenuse is 13. Using the Pythagorean theorem, I can solve for my adjacent side, which has to be 12. Now I can use this triangle to help me identify my cosine. I can go ahead and plug things in. So I know that the sine of u is 5/13. I can identify the cosine of u as 12/13. And then when we fully simplify everything, we get 120/69 as our final answer. For our cosine of 2u, once again, we want to look at our formula. In this case, we need to identify the cosine and the sine. We're going to do this for our same angle u from the previous example. So that means that we have our same triangle, where we have our adjacent side is 12, the opposite is 5, and our hypotenuse is 13. So from this triangle, we can identify the cosine and the sine and plug them in. And if we do, we get 12/13 for the cosine and 5/13 for the sine. Plugging them into our formula, you see that we are going to be squaring each one of those. So when we square them and subtract them, we end up getting, for our final answer, 119/169. And for our final example, we're going to go ahead and find the tangent of 2u, once again using the same triangle. Looking at our formula for this, we have that the tangent of 2u is 2 times the tangent of u over 1 minus tangent squared. This is definitely the most complicated of the three formulas. And in order to use our formula, we're going to identify the tangent, which is the opposite of the adjacent. So for my numerator, I have 2 times 5/12. And for my denominator, I have 1 minus 5/12 squared. When I simplify things a little bit, I have 5/6 for my numerator, 119/144 for my denominator. So I'm going to multiply by the reciprocal of that fraction to end up getting my final answer of 120/119. Moving on to our next set of formulas, we have the half angle formulas. So we have the sine of u over 2, we have the cosine of u over 2, and then we have the tangent of u over 2. Again, we're going to go ahead and apply this to a situation so we can go ahead and look at how to use them. If we consider our same angle u, we have the same triangle with opposite, adjacent, and hypotenuse. And for our formula for the sine of u over 2, we have plus or minus the square root of 1 minus cosine of u over 2, which means I need to identify from my triangle the cosine. So I'm going to go ahead and identify that and plug that in. We have 1 minus 12/13 over 2. If I simplify my numerator, I end up getting 1/13 over 2. Simplifying that a little bit further, we have the square root of 1/26, which rationalizes to be the square root of 26/26. And notice one thing, I did lose the plus or minus. The plus or minus is there to kind of ensure that we have the correct sign for our angle. And this really applies more to angles from like a unit circle. So for example, if I had an angle like 75, half of that would end up being a positive angle. So you want to make sure that you continue to have a positive value. If I had, let's say 315, half of that might end up being negative. So you want to make sure that you preserve the sign of your angle with the plus or minus. For the most part though, our angles are generally always going to be positive. Looking at the cosine of our same angle, for our formula, again, we're going to be using cosine, but this time it's 1 plus instead of 1 minus with our formula. So you can see we have 1 plus cosine of u over 2. So I identify that for my triangle, and I get 1 plus 12/13 over 2. If I add my numerator together, I end up getting 25/13 divided by 2. When I simplify that, I have radical 25 over radical 26. And if you rationalize that, you get 5 radical 26 over 26. Again, notice the plus or minus did go away for the same reason I mentioned in the last slide. For the tangent of u over 2, you see again we have the more complicated of the three formulas. We're going to need the sine and the cosine because our formula says sine of u over 1 plus the cosine of u. So identify those from our triangle. When we go ahead and plug them in, we get 5/13 over 1 plus 12/13. I'm going to go ahead and combine my denominator here to get a single fraction, which gives me 5/13 over 25 over 13. And as I continue to simplify, I end up getting 1/5 as my final answer. For our next batch of formulas, we have product to sum. And what we can see here is on the left side, we have the product of two formulas. And we're going to be expanding that using the following formula. So if we have sine times sine, then it's 1/2 cosine of u minus v minus cosine of u plus v. If instead we have cosine times cosine, well, we have the same formula, but instead we're going to be adding the two together. So I have 1/2 cosine of u minus v plus cosine of u plus v. So if the sines are both the same, then we're going to be subtracting. If instead both functions are cosines, then we're going to be adding for this formula. And for the second part of these formulas, you can see if we have a mixture of the two, if we have a sine and a cosine, it definitely matters which one is first. So if I have sine of u times cosine of v, then I have 1/2 sine of u plus v plus sine of u minus v. If it said cosine is first, then for the cosine of u times v, I have a similar formula, 1/2 sine of u plus v, but now it's minus sine of u minus v. And for the most part, I'm not expecting you to memorize these formulas. I just want you to recognize if I have sine times cosine, it's this formula. Whereas if we have cosine times sine, then we're using the other formula. So I want to make sure that you know how to use them, not that you're memorizing which one is which. All right, so for our first example, we're going to write this as a summary difference. We have the cosine of 2 theta times the cosine of 4 theta. So we're trying to identify our pattern here. Do we have both sines, both cosines, or is it a mixture? In this case, we have both of them being cosine. So when we go to choose the correct formula, we can see that we have 1/2 of cosine u minus v plus cosine of u plus v. We're going to go ahead and simplify our expressions on the inside. So we're going to simplify the 2 theta minus 4 theta and the 2 theta plus 4 theta. And we get 1/2 cosine of negative 2 theta plus the cosine of 6 theta. And at this point, we want to simplify using our even and odd identities and try and recognize, since we have the cosine of negative 2 theta, how do I simplify that negative sign? And in this case, the cosine of negative 2 theta is the same as the cosine of positive 2 theta. So the negative sign just disappears, and we have our final answer written as a sum. All right, for our next example, we have 5 times the sine of 3 theta, cosine of 5 theta. There's something that's a little bit different with this problem. We have a 5 in front, and we're going to talk about how to deal with that specifically. But we do notice that we have sine times cosine, so based off of that, we want to identify the correct formula to use to expand this. And since it's sine times cosine specifically, we have 1/2 of sine of u plus v, and then plus sine of u minus v. And notice this 5 that's on the outside is still there. We just multiply that by our formula. So if there is a coefficient in front, you multiply that by the 1/2 on the outside. As we go through and simplify our angles, we can add 3 and 5 together, and then we can subtract 3 and 5. And so we get 5 over 2 times the sine of 8 theta plus the sine of negative 2 theta. Once again, we want to simplify this. Unlike the cosine, though, the negative sign does not disappear. Instead, it gets pulled out to the front of our function. So now we're going to have 5 over 2 times the sine of 8 theta minus the sine of 2 theta as a fully simplified sum. One last example here. We have 5 sine of 3 theta, sine of 4 theta. Again, that 5 is on the outside, so we're going to make sure we multiply that by our 1/2. And since we have sine times sine, that identifies which formula we're going to be using. So when I plug in my u and my v, you see that we have, again, our 5 times the 1/2. And then for the expansion, it's cosine of u minus v, and then minus cosine of u plus v. We're going to simplify our expressions, the 3 theta minus 4 theta, and the 3 theta plus 4 theta. And we get cosine of negative theta, and then minus cosine of 7 theta. And then once again, we want to make sure we simplify this negative sign. Since it is a cosine function, that negative sign is going to disappear, and we have 5/2 times the cosine of theta minus the cosine of 7 theta. All right, if we wanted to go backwards, if we have a sum or a difference and you want to write it as a product, again, it matters what we're doing. So notice if we have sine plus sine, then the formula is 2 times the sine of x plus y over 2 times the cosine of x minus y over 2. And then if instead we are subtracting the 2, we're going to switch functions. So we have cosine first, and then we have sine second. So it's again identifying the pattern of do we have sine plus sine or sine minus sine. It's going to dictate what version of our product formula we're going to be using. If instead we have cosine, so we have cosine plus cosine, then notice we have both functions are the same, they're both cosine. If instead we are subtracting, then we have a negative sign and they are both sine functions. So once again, we have two more examples of it really matters what function we have, and then are we adding, subtracting to dictate what form of our product formula we're going to be using. All right, for our first example here, we're going to write the cosine of 120 plus the cosine of 30 as a product. So in order to do that, we're recognizing we have cosine plus cosine, which tells us we have 2 times the cosine of u plus v times the cosine of u minus v. So we plugged in our u and our v value into our formula. When we go ahead and add them, we get 150 over 2 and then 90 over 2. And then last but not least, we want to go ahead and simplify that. So we have 2 cosine of 75 plus a cosine of 45. For our next example, we have sine of x plus sine of 7x. Since we have sine plus sine, that'll tell us which form to use. So you can see that we have 2 times the sine of u plus v, and then cosine of u minus v. We're going to go ahead and simplify some things. So we have 2 sine of 8x over 2, and then cosine of negative 6x over 2. Let's add that x in. If I continue to simplify things, then we have 2 sine of 4x over cosine of negative 3x. And then the last thing we have to do is manage this negative sign in there. It goes away, and we have 2 sine of 4x cosine of 3x. And for the final example, we have cosine of 120 minus cosine of 30. So notice that we have 2 cosine functions, and we are subtracting them, which helps us identify which form to use. When we go ahead and plug it into our formula, because we are subtracting, we have that negative 2 on the outside, and then we have sine of u plus v, and then sine of u minus v. When we simplify some things, we can add our 120 and our 30 and then subtract the other set. So we get negative 2 sine of 150 over 2 and then sine of 90 over 2. Simplifying that a little further, we get negative 2 sine of 75 and then sine of 45. All right, guys, that does it for our notes for this section. Go ahead and get started on the homework. Good luck.